Okay, so our next question here is really quite a simple one, and you'll see I'm going to be very, very quick when explaining this. This is taken from the September CT8 2014 examination. Now, they say Company A and Company B are joint investors in a high-risk project to build a new space plane. Each of the two companies' zero coupon bond are modeled according to a two-state model. That is extremely important. Now they say companies A bond have a recovery rate delta, let me use a different highlighter, of 60%, while company B has a recovery rate of 50%. All bonds matures in 9 months, right? Company A's bonds have a current price of 82 per 100 nominal. So this is the value, okay? This 100 is your redemption value, and this is the price at time 0. And company B bonds have a current price of 79 per 100 nominal. So your redemption value and your price at time 0 again for company B. The continuously compounded risk-free rate is 1.5. Okay. Now, unfortunately here, I am very sorry, please forgive me. I skipped a question here because you see here this starts in part 2, but there was actually part 1 of this question. The part 1 of the question says describe the two-state model and how it can be extended to the Gero-Lando-Turnbull model. Now, under the two-state model, now let me quickly explain this before I do the numerical question. Now, under the two-state model, we have two states, which is no default, and another state, which is default. And we have the transition rate lambda of S. Okay, so this model is continuous in time with two states, as you can see, and lambda of S is the transition intensity under the real world. And if you look at this state here, you can see once you have entered the default state, there is no way you can leave it. So the default state, which is D, is the absorbing state. Now, it is also assumed that after default, all bond payments will reduce by a known factor, which is 1 minus delta, where your delta is your recovery rate. And you know, we've been discussing that under the two-state model, the price at time little t for a bond maturing at time t, paying 1 at time big T, is equal to e to the power minus r into t minus little t, multiplied by 1 minus bracket 1 minus delta times the probability of default under the two-state model, which is 1 minus e to the power of minus delta from little t to big T lambda of S ds. So you are integrating your transition intensity with respect to S, and you close that. Remember, I've been stressing this. This is the probability of default under the two-state model. So this is how we value the price. Now, and we have to, the question asks you to explain how this two-state model can be generalized to a Gero-Lando-Turnbull model. Now, the Gero-Lando-Turnbull model generalizes the two-state model into n-1 credit ratings. What do I mean by credit ratings? So it is the state. If you think about your CT4, your CS2, if I'm not mistaken, your state in this section of credit risk, we call them your credit ratings, plus default state. So this state, so the Gerolando 10 bill generalizes the two-state model to N-1 credit rating plus the default state. Obviously, for this model, your default state will be your absorbing state. Okay, so that is your explanation, but that is your bookwork. You can always go in your note and check it, and make sure that you are able to explain this in your examination properly. Now, part 2 of this question, they say, calculate the implied risk neutral default intensity, lambda A and lambda B, assuming they are constant. This is very, very important, because if there were functions of S, we were going to do something. This, assuming they are constant, makes our algebra very, very easy. Now, for bond A, under the two-state model, we know now our initial time is 0 here, and our final time is 9 months. But please be careful, you cannot work with 9 months, as you are given your risk-free rate per annum. So these and this must match. This is per annum, this is also must be per annum. Okay, so I'm going to work with 9/12 instead of 9 months. So for bond A, the price of bond A, the question told you, it is 82, right? And the redemption value is 100 times e to the power of your risk-free rate, which is 1.5 multiplied by 9/12. That's multiplied by 1 minus 1. 1 minus your recovery rate for bond A, which is 60%, multiplied by the probability of default, which is the expression I am writing here. Okay, this is the probability of default, but the examiner is looking for the transition intensity. So how do I solve this equation? Just a little warning here, and you will notice that I did warn you in the previous session. Please, here you cannot simplify this equation by saying 1 minus 1, you get 0, then distribute this 1 into this plus to get plus 60% multiplied by this. You may not do that, because here this is similar to saying 1 minus 2x. So this x is this whole thing here, and this 2 is this number here, and this 1 is this 1 here. And you know there is no way you can simplify this 2 minus x. You just can't do that. So please, I know it looks very tempting to say 1 minus 1, but please do not do it. So the first thing I'm going to do, I'm going to divide by this on both sides. Then this is actually a package, if you think about it. It's a package multiplied. So I'm going to divide by this on both sides. Then I'm going to take this passage, bring it to this side of the equation, then take my division and bring it to this side of the equation. Now that is basic algebra there. I'm not supposed to be explaining such. Now, if you do that, you are actually going to have 1 minus 82 over 100 multiplied by e to the power minus 9/12 times 1.5%. Let me quickly check, is your risk-free rate 1.5%? Yes, it is 1.5%. Just wanted to make sure. Right? So what I'm actually saying, I'm saying 1 minus this whole thing while this package is this side. Obviously, this here is 0.4. So I've still got to divide this by 0.4. Now, this will be equal to 1 minus e to the power of the e to the power 1 minus e to the power of negative integral from 0 to 9 over 12 lambda a ds. So now I have to take this to this side of the equation and say 1 minus this. Basic algebra. And you'll be sitting with your calculator, so you don't have to worry. So I'm going to say 1 minus this, which will give me 0.5731927144. And I'm going to natural log on both sides. I'm going to put a log on both sides so that I have minus 0 to 9 over 12 lambda a ds being equal to, now this minus I'm going to multiply it through so that I have minus this value here. Let me highlight it in yellow. This value here is the value you're going to put here. Now your lambda is a constant, so I can perform the integration there. It will just be lambda a multiplied by 9 over 12. Please make sure you are able to perform your integration. So now I can find your lambda, which is your transition intensity. Now your lambda a will be equal to minus the natural log of 0.5731927144, and I'm going to divide this by 9 over 12. Sorry. And you're going to punch your calculator there. Nothing major there. I'm just solving an algebraic equation, which should present no problem. So I'm going to get lambda a to be 0.742044. Okay, now I'm going to do a similar thing for lambda b. Now I won't waste any time. It is the same procedure, but now your prize will be for bond B, which you are giving to be 79. Your redemption value will be 100. Your delta now will be 50, and you're going to do the same procedure. And you're going to land up with a lambda B, which is the transition intensity for company B, to be equal to negative natural log of 0.5978753604, and I'm going to divide this by 9 over 12. This is what you're going to land up with after performing the algebra I performed here. So I'm going to have lambda b being equal to 0.685830. Okay, that wasn't very bad. It's just manipulating the algebraic equation. Now, the last part of this question gets very interesting, because now they're saying a competitor to the space plane project now start to sell a derivative security which pays, now they're talking about payoffs, which pays $100,000 excuse me, at the end of 9 months, if and only if both companies default within the 9 months. The current price for this derivative is $7,900. Now they say calculate the risk neutral probability of a double default and the corresponding constant rate. Now, this is actually an interesting question because they are using something we derived in the 5-step method in this section, because here now we do not have recovery rate and all those things, so we can't use this formula here, but we use the formula that we derived in the 5-step method. If you remember very carefully, I've got a revision on the 5-step method, but if you remember very carefully, the price at time little t of a derivative which pays xt at maturity is equal to e to the power minus r into the maturity time, the final time, minus the initial time, times the expected value of the payoff at maturity given the past history. Okay, this was derived from the 5-step method. Okay, it is very important for any section in this paper. As you can see, popping up in credit risk, so you have to be able to apply it in any section. So now here, this is the expected value of the payoff discounted at discounted. Okay, so this is the discounted factor. Now, the expected value from your basic studies, you know that the expected value of any random variable is given by the value times its probability. Okay, the expected value is given by the value times its probability. So, but here it is the expected value of the payoff. So I'm going to take the payoff times the probability of that will result in this payoff, and I have to discount it. So your price at time 0 will actually be equal to e to the minus the risk-free rate multiplied by your 9/12 times the expected value of the payoff. Now, the question told you that we pay off 100,000, so we pay off 100,000 times the probability. Now, this 100,000 will be paid if and only if both companies default. So I have to multiply this by the probability that both companies will default, and I'm going to call that XD. Now I'm given the price to be 7,900. So I'm actually going to remove this and put 7,900. Now I'm going to solve for XD then, which is not difficult at all, because now I'm going to divide by, pink is not a good one. I'm going to divide by this whole thing on both sides in order to get this. So doing the division there, you're going to get your XD to be equal to 0.07989. Now, this is a probability of a double default, but the examiner didn't only ask me the probability of a double default, they asked me the corresponding constant rate. Now remember, if this is the probability of default, under the two-state model, the probability of default is given by 1 minus e to the power of integral from minus the integral from 0 to 9/12 of your transition intensity ds, and that must be equal to the probability of default, which is 0.07989. And from here, I'm going to solve for the probability of a double, sorry, I'm going to solve for the transition intensity of a double default. Obviously, we're assuming that this is a constant. So I'm going to say 1 minus this, then take natural log on both sides, do the integration, divide by 9 over 12. You can do that algebra. I actually don't have the answer to that, but it is what I'm explaining here. Now, the last question here says, now let me erase this so that you can see. Now, our last question here requires a little bit of consideration, because now they're saying calculate the maximum price for this derivative by considering the maximum possible double default. Now, the key word here, we're looking for the maximum price for this derivative by considering the maximum possible default. Now, the important thing to notice here, we can see that a double default will happen when both companies default. And if you think about it very carefully, this can't happen faster than the minimum of the rate of default of A and the rate of default of B. Okay. And if you substitute lambda A and lambda B, the one you calculated in part 2 of the question, you will see that the minimum is actually lambda B. So the maximum price, we're going to have the maximum price when the transition intensity is lambda B. Now you can calculate the maximum price, because now I'm going to say the price is actually equal to, again using the formula derived under the two-state model, sorry, on in the 5-step method, using that formula, I'm going to call this P star, price star, a payoff of 100,000, but I have to discount this. So this is your discount factor multiplied by the probability of default, but we see that the maximum price will occur when we have the transition intensity for B. You do have this. You can calculate this value here, right? You do have lambda B. You can do the integration here, and you're going to get your P star to be $39,376. So that is your maximum price. Obviously, you could have tried different intensities. So you could have worked here with the intensity of A, find the price, work with the intensity of B, find the price, work with the intensity of both of them, find the price, and you will see that the maximum price out of those prices you're going to have is when the transition intensity is that of B. Okay, so that was a little easy question. Obviously, the last part you had to think needed a little bit of consideration. Now, our last question of our revision, again, deals with something which is very important. Now, this question here deals with the application of the Gerolando-Tyndall. Now, this question here is taken from the April, this is not 2018 if I remember rightly, it is April 2017 examination. So, sorry for this. Now, the first part of the question says, draw a diagram to illustrate the Gerolando-Tyndall model for credit default, defining any notation. Now, this is the bookwork, sorry. This is actually your bookwork, which you must remember in your examination. So, this is what the examiners are looking for. This is the diagram that the examiners are looking for. Your state, remember the Gerolando 10 bell is the generalization of the two-state model with n minus one state, and n being the absorbing state, as you can see there. And please show your transition intensities then. Right. So this is the n state representing the n minus 1 credit rating plus default. So this is the diagram the examiner is looking for. Okay. And define these transition intensity. So lambda ijt are the deterministic transition intensity from state I to state j at time t under the real world. Okay, let's go back to our presentation. So I've shown you the answer to this. Obviously, this is your bookwork. You just need to make sure you recall it. Please know it. It is a very common exam question. Now, the next part of the question is where we apply our Gerolando 10 bell. Because now what they're saying, they say, consider a three-state credit model for a company in discrete time. The states are healthy, unhealthy, or default, which is D. And the transition probabilities from state I to state J, denoted by these, are constant, and they are given here. So this is a transition probability from the healthy state to an unhealthy state, unhealthy to healthy, healthy to default, unhealthy to default, default, the probability of from default to any other state which is not equal to the default state, we're going to have a probability of 0 then. Now, because I know you are familiar with CT4 or CS2, I'm going to represent this in a transition matrix. Okay, I'm going to represent this in a transition matrix so that we can see how to do this question here. So I'm going to have my healthy, unhealthy, default, healthy, unhealthy, default. The probability of moving from H to U, the examiner told you that is 0.1 from the given question. So 0.1, the probability of moving from healthy to D is 0.02. From healthy to healthy, you don't have that, but remember the sum of your row. So your sum of your row in the transition matrix must add up to 1. So this is actually equal to 1 minus this, which is 0.88. Okay. The probability of moving from U to H is 0.05. From U to U, we don't have. From U to D, you are giving it to be 0.3. Remember, the sum of these, the sum of entries in this row must add up to 1. So I'm going to have 0.65 there in order for that to happen. And from D to H, the examiner told you that is 0. The probability of moving from D to any other state is 0 if that state is not equal to the dead state. So, but your rows must add up to 1, so I must have 1 here. So this is your transition matrix. Now, they are saying here, the company is in the healthy state at time 0. So at time 0, we are in the healthy state. Now calculate your PD2. which is the probability that the company is in the default state at time 2. Now, from your subject CT4, this is actually matrix multiplication, because if I think about this, if this is time 0, and this is time 1, and this is time 2, this matrix here represent transition probabilities from time 0 to time 1. If I take this matrix here and multiply it by the same matrix again, I'm going to get transition probabilities from time 1 to time 2. So what am I saying there? Let me quickly finish up this video before it's too late. So I know that when I take these matrix, I'm going to get the matrix of from 2 at time 1 to time 2. Now, I am told in the question that we are at time 0, we are in the healthy state. So if I take this column here, and multiply it by the last row, right? Do you agree with me that I will get the last entry here, which is D, which is default? Do you agree with me? I'll get the last entry here, which is default, given that we were in the healthy state at time 0. So I'm going to take this row, multiply by this column to get this entry here, which will be the probability that at time 0 we were in the healthy state, and now at time 2, okay, after multiplying these two, at time 2 we are in the default state. So I'm going to take this and multiply it by this in order to get this, which is the probability that at time 0 we were healthy, and at time 2 we're in the default state. So I'm going to do the multiplication now. So the probability I'm looking for will be given by 0.88 multiplied by 0.02 plus 0.1 multiplied by 0.3 plus 0.02, matrix multiplication. This will be equal to 0.0676. So this is the probability of being in the default state at time 2, given that we were in the healthy state at time 0. Now, please, we multiply our matrix 2 times so that we can reach time 2, right? This entry here of the resulting matrix after multiplication, this entry here, which is in column D, is the probability that we were healthy at time 0, and now we are in default state. But I'm sure you have been doing this in subject CT4. Now, the second part of the question gets even more interesting, because they say the company issues a 0 coupon bond at time 0 with a maturity at time 2. Okay, and nominal value of £100. Now they say the continuously compounded risk-free rate of interest is 4% per annum. So that's your R. Now, the next part here is the one which I find confusing to most people get confused. And again, here we use the results derived in our 5-step method. Now, they are saying assume that the bond returns. Now, which is a payoff. Let me use a different highlighter. Now they're saying assume that the bond returns its nominal value at time 2 if the company is not in default. Okay. Or we are saying or or it returns X percent of its nominal value at time 2 if the company is in default. Now this is a payoff because we're going to get its nominal value if it's not in default, or X percent of its nominal value if it's in default. Now they give you the price of the bond at time 0 to be this, and they ask you to calculate the value of X. Now this again, we're going to use that results we derive in the 5-step method, because if you remember, we said that the price at time t in the 5-step method is the expected value of your payoff at maturity discounted times your discount factor. So your payoff is 100 if the company is not in the default state. So what is the expected value times the probability that it is not in the default state, which is 1 minus 0.0675. Remember, here is the probability that it's in the default state. 1 minus is that it is not in the default state. Or we're going to get X of its nominal value if it's in the default state. So the expected value will be 100x the value times the probability that it's in default, which is 0.0676. Okay, don't forget to discount this. So I'm going to multiply this by minus 2, this is for 2 years, times your risk-free rate. The examiner told me that my risk-free rate is 4%. So I'm going to have 4% here. This will give me the price at time 0, which the examiner told me is 87.63. As you can see, this formula here is very, very important when we are not given the recovery rate. The expected value of the payoff times the discount factor. It is extremely important, and please remember, at the moment they talk about the payoff, please think about this formula and associated probabilities. Now you have to solve for X here. You're going to divide by this on both sides, subtract this, then divide by 100 times this. And that is the equation you can solve. I'm sure you're going to get 0.248. Rounding off, you're going to get 25%. So that is your value of X. Now, our last question here says, calculate the credit spread on the bond. I've been explaining this. Your credit spread on the bond is the redemption value on the bond. Sorry, is the redemption yield on the bond minus the risk-free rate. So how do we calculate the redemption yield on the bond? We're going to discount our redemption value at a yield RY for 2 years. There we're going to get the price, which is 87.63. And if you solve there, you're going to get, you can solve this equation, I'm sure. Divide by 100, take the natural log and divide by 2. You're going to get your R to be equal to what? Seems like I don't have. Now you're going to say natural log of 100 divided by 87.63. All of that divide by 2. So this is your redemption yield on the bond. From this value here, you're going to subtract your risk-free rate, which is 4%. And oh gosh, sorry, I'm rushing to finish this video because of time. This is the redemption. This is the redemption yield on the bond. Your credit spread is given by your redemption yield on the bond, which is RY. You're going to calculate it here, minus your risk-free rate. And you can use your calculator there. I don't have the actual answer. I'm sorry, I left this part of the question. Now, the last question says, comment on the impact of the current price of the bond if it returns X% of its nominal value at the time of default rather than at time 2. Now, here, the default might happen before time 2. So the price might do what? Might increase, okay? Because the default can happen before time 2, because the question says the default can happen anytime. Okay, it was great. It was great being with you. I wish you all the best with your exam revision. Bye-bye.